Welcome back, everybody. Brandon Steckler, Technical Editor of Motor Age Magazine, back again for the latest episode of Mastering Diagnostics. I can't believe we're on episode number 14 already. You might not recognize the background. I'm actually at my new home in New Hampshire. Yep, I made the trek up from just northwest of Philadelphia all the way up to Ossipee, New Hampshire. It's beautiful out here, and I'm real excited to be in this area. So for the meantime, until my office is set up, I'm filming from my kitchen. Today, I want to talk about a topic that's very valuable to me. And that topic is what I refer to as the bypass test. Now, let me tell you what the bypass test is designed to do. What it's going to do is allow you as the technician to prove that the fix you are prescribing is actually going to repair the vehicle. And it's a tremendously powerful test. Now, it can't be applied in all situations, and you'll understand that as the video progresses. But in many situations, taking the time to simply gather information about how the system functions, what the components are that make up that system. In other words, the players in the game is what I'd like to call it. If we understand how those components work together to accomplish a goal, we can reverse engineer that system. And once we reverse engineer that system, we can use our own testing techniques to prove out or bypass the fault to make the system function. So just a quick, easy to view example of a bypass test. This simple pull down circuit of a light bulb is supplied battery voltage through a fuse to the bulb, and the bulb is supplied a ground path through a switch. But as you can see here, there's some voltage drop, some gunk, some resistance built up on the contacts of that switch. So with that switch closed, this light bulb isn't working. But implementing a fused jumper wire to bypass the suspected switch, we've provided a healthy ground path. We've bypassed the suspected voltage drop. And by doing that, providing a healthy ground path, now the light bulb can operate as designed. So this is what I'm talking about when I reference a bypass test. And of course, this is just an easy to view example, so you know what it is I'm talking about. But we will implement it on a live vehicle problem. And the idea is it's going to save us a bunch of time. So the importance of the bypass test is going to allow us to prove things out prior to committing to a repair. Lots of times that means preventing us from having to disassemble the vehicle before a repair is approved, before parts are available and things of that nature. In the long run, it's just going to keep us more efficient. And it becomes ever more important when the customer decides maybe they don't want to invest in the repair. The last thing I want to do as a diagnostician is take something apart for no reason. And if I do take it apart, I certainly wish to be paid to do so. So you can probably relate to where I'm coming from. But anyhow, back to the story. So I've got my 2006 Chevy Silverado. And the story is this. On my move up here to New Hampshire, I was dollying my Honda Civic behind my truck. And there's some steep inclines on the way from Philadelphia up to Ossipee, New Hampshire. So I wanted to place my truck in a feature called tow haul mode. And it's simple button press on the gear shifter that tells the computer I desire more torque, and it won't allow things like an upshift, or it will hold gears longer as I accelerate through the RPM range. But in a nutshell, it just didn't work. And I thought to myself, crap. But it is what it is. I got the vehicle up here and everything's just fine. So now it's time to address it. So what we're going to do is, in order for the bypass test to be applicable, we're going to have to know where to bypass. What I mean where is where in the wiring diagram, what component we are going to bypass, and where on the vehicle physically we can access the circuit easily to create this bypass test. I'm going to be accessing my service information system to educate myself on how this circuit has been engineered. As we know, there's a million ways to skin a cat, and there's a million ways to make a circuit or system function. So we need to research that ourselves to understand. So we're going to do that now. So with the wiring diagram pulled up, referencing what I need to make this diagnosis, to create this bypass test, you can see over here is our tow haul switch. And this is a simple pull down circuit from the body control module. So the body control module is going to output a reference voltage, and I don't yet know what that reference voltage is going to be. It might be 5 volts, it might be 12 volts. It doesn't matter. I just need you to know that we can tell by looking at this diagram that a reference voltage is sourced from the BCM. Being a pull-down circuit, this tow haul switch, integral to the shifter assembly, is going to provide a ground path to G203. When that ground path is provided, the body control module is going to see this signal get pulled low, pulled towards the ground. What the BCM is then going to do is get on the telephone, on the Class 2 data bus communication network, and talk. It's going to send that message on a party line out to the instrument panel cluster, which is going to give us our indicator. This is the indicator that was not working. That's how I knew the system wasn't functioning. This is going to be the command to the cluster to turn on the indicator. At the same time, that same message, that communication network, is going to deliver that message to the powertrain control module. And this is where the PCM is going to make decisions about how to operate the transmission to accommodate tow haul mode versus without tow haul mode. So what I see is a body control module, a powertrain control module, and an instrument panel cluster. And all three of these computers I can access with a scan tool. So let's think about what we just discovered by viewing that wiring diagram. The body control module, again, outputs that signal to be manipulated by the tow haul switch. By looking at the body control module data, assuming that data is available or viewable with my aftermarket scan tools, I could be able to tell whether or not that body control module is seeing that switched input. Taking that a step further, rather than looking at the BCM, I could simply look at my instrument panel cluster for the same data. If my instrument panel cluster or my powertrain control module is indicating the tow haul switch has been depressed, it proves that the body control module had received that signal. Think about that for a minute. Think about that, how powerful that is. This is one more set of tests we don't have to do. So rather than going to the body control module, I'm going to go directly to the powertrain control module, or directly to the instrument panel cluster, or maybe both, and see what's going on. Maybe there's nothing wrong with the switched input at all. Maybe the switch is working correctly. Maybe the body control module is seeing that information, and maybe it's commanding the powertrain control module to place the transmission in tow haul mode. But perhaps the bulb in the cluster that indicates, that allows the indicator to be visible isn't functioning. So these are all questions that I derived simply by viewing the wiring diagram. And here's the takeaway. I'm still sitting at my kitchen table. I haven't even looked at the vehicle yet. So learning to think logically before we roll up our sleeves and get dirty might seem counterintuitive. It might seem like I'm wasting time here, but the time spent developing my diagnostic game plan saves me from having to take things apart on a vehicle because I'm taking the time to use logic. Using an understanding of how this system is configured and our knowledge of electricity, we can come up with a game plan quite simply. Well, I tried to do the easiest test first. And of course, from the driver's seat, I tried to reference the information I desired. I tried to look in the body control module, and I tried to look in the instrument panel cluster, and I also tried to look in the powertrain control module for the tow haul switch signal input. And the software in my aftermarket scan tools was not robust enough. It didn't contain that information. Now, there's other solutions. If I was equipped at the OE level, if I had access to the Tech 2 OE scan tool or applicable Windows version of that tool, I could easily obtain this information. But rather than do that, let's pretend that the information was not getting to any of those computers. Let's pretend we did that. Let's pretend we made a purchase through NASTEF for temporary use of the GM scan tool. And by viewing information from the body control module and from the PCM and from the instrument panel cluster, when I depressed the button, there was no indication in any of those control units of a change of state in the tow haul mode switch signal circuit. We're going to pursue the vehicle's problem, keeping that in mind. So let's head back to the wiring diagram and further pursue our diagnostic game plan. To the drawing board again. We're trying to develop a diagnostic game plan on where to perform our test most logically. So again, to recap, we've viewed the body control module and we can't see any data indicating the tow haul mode switch signal circuit has been manipulated. There's no change in state. We can't even view that data. So I want to determine how best to test this system. Ideally, I would love to be at the body control module because the circuit originates here and we can place it to ground. If there's an open somewhere in this circuit and I test south, in this case in this direction, below that test point, it's going to show open. It's not going to show any voltage. So I want to be as close to the BCM as possible. This will let me eliminate as much as possible. So the question then becomes, where is the body control module located? Could I perform this test at C201 terminal B5? I sure could. Could I perform this test at the tow haul switch? I absolutely can. But I know for a fact where that tow haul switch is located, and I will have to remove the steering column bezels to even get to that wiring. So I'm not saying I won't test here. I'm saying I'm not going to choose to test there first if there's an easier place to test. So I went ahead and saved some documents on the locations of connector 201, terminal B5, and the body control module, connector C3, terminal B11. So C3 is going to be the brown connector. So if I go back to my saved bookmarks here, 201, this connector right here, let me see if I can zoom in this further. B5, light blue, is located right here in this area. Here's 1, and here's 8, so 5 would be here. The location of that connector, though, again, is adjacent to the steering column, which means I'd have to remove the knee bolster and such to get to that. And I'll show you pictures of that when we head back out to the vehicle. The body control module, however, is located just below the steering column. And if we go out to the vehicle, I can actually see there's a little gap in this area between the steering column to allow room for it to tilt. The steering column mounts right in here. And I can actually see all these connectors. I can also see the blue wire that comes out of this brown connector located in this area right here. We are going to test at the body control module as close to it as possible to see if that signal, first of all, is available. I should anticipate voltage being available, leaving the body control module at that blue wire. If voltage is available, I'm going to depress the switch and see if that voltage gets pulled low, because remember, this is a pull-down circuit. We've identified that from the wiring diagram ahead of time. Being able to build a diagnostic game plan like this allows you to anticipate what your test results should be and what it means if it is not what you expect it to be, meaning what test are we going to perform next. So we're going to head out to the vehicle and perform that first test.
Okay, so we are under the dashboard. I haven't removed anything at all yet. And we can see right here is our brown connector. And this is terminal B5, so I'm going to connect my Pierce probe as a means to gain access to the circuit. And now that my Pierce probe is connected, we're going to connect our meter and test. So I'm trying to do this one hand. I'm going to connect my DVOM red lead to our test point. And I'm going to take our DVOM ground lead and, let's see if I can get it in the picture here. And I am going to connect it to terminal 4 of our data link connector. Terminal 4 or terminal 5. Terminal 4 is signal ground. This circuit carries virtually no current at all, so this is safe to do. I'm going to turn on my meter, and we see, well, 11.6 volts. I've had the key on for a little while. I'm going to come over here and press the button so you can hear it. Let's go down to the meter and look. Button on now. No change. No ground path.
At this point, what we already know is that the BCM is doing what it's supposed to do so far. It's outputting that voltage. However, at this point in time, I have enough evidence to say that the body control module is doing what it's doing, and I also have enough evidence to say that the ground side of the circuit has been compromised. So this is where I'm going to implement the bypass test. Our body control module outputs a reference voltage, and that voltage is pulled low through a ground path by way of the tow haul switch referencing G203. But since that's compromised, I have to create my own ground path. So I'm going to continue to back probe the circuit, and I'm going to use a jumper wire and a known good ground path to manipulate the circuit. What should happen? The BCM should see this as a switched input, just as it would see the tow haul switch, assuming it was functioning properly. The body control module should then communicate that request for tow haul switch mode, excuse me, on the Class 2 data network to the instrument panel cluster and the PCM. The cluster should see this request and command the tow haul indicator to be illuminated. And at the same time, the powertrain control module should force the transmission into a mode where it creates more torque for a longer period of time. So again, we'll head out to the vehicle and we'll perform this test. What this test is going to allow us to do is first prove that the system is functioning, and which will also allow us at that point to tell our customer that the problem is downstream from my test point here, downstream from where this red alligator clip is. At that point, if the customer chooses not to fix the vehicle, we have very little time invested, but we already know what's wrong. If they do choose to fix the vehicle, we've already proven that the problem's downstream, and we will definitely find it if we pursue it further.
And you can hear, switch on, no change, so we've lost the ground path. Let's perform our bypass test now. Let's take a look. If I were to connect my ground lead from my meter here to my T, which is pierced to our terminal B5 of our BCM, it will ground that signal. So what I'll do is I'll pull this out for now. I will plug this test lead into my T. Oh, I'm struggling here. And now what I'm going to do is provide a ground path by touching it to terminal 4, and we are going to watch what happens on the cluster. So let me zoom in a little bit. I'm going to simply touch it and take it off. Touch it again and take it off. Touch it again and take it off. Let's go look at the cluster. On, touch it, goes out. Touch it again, comes on. Touch it again, goes out.
So, knowing what we know by back probing the circuit at the body control module and seeing voltage available, and that the voltage will not be pulled low with the tow haul switch closed, we can conclude that the ground side of the circuit has been compromised. When I mean ground side, I mean anywhere from my test point south, as driven in this diagram. So could we have a bad tow haul switch? Absolutely. But this tow haul switch is located on the shifter, and I'd have to disassemble the steering column bezel just to get to it. I'm not saying I won't do that, but I certainly don't want to try to do that first. C201 is located halfway up the steering column and would require removal of the knee bolster for access. So I'm not saying I won't go there either, but what I am saying is I don't want to go there first. However, G203, we don't even need the vehicle to test that. Let me show you what I mean. G203 is here, and there is a second page. Look at all the components. I don't even have to go to the second page. Here's G203 right here. We've got the digital radio receiver, an amplifier, rear seat audio, a vehicle communication interface, the HVAC control module, of course the body control module, the cruise control, the door lock switch actuator. All of these components require a good path to ground at G203 to function. So what I'm getting at is, why the heck would I want to go test G203 when right from my kitchen table, I can tell you that all those other components seem to work just fine? G203 simply cannot be the issue. So that's one thing I'm not going to waste any time testing because it's simply not necessary. We've already proved it works. G203 has good integrity because all the other components that use G203 work just fine.
So right now I'm at connector 201. Sorry about the glare. Here's my test probe. I'm connected to the blue wire at 201, just behind the knee bolster. Once again, we are showing our 11 volts. Listen, I'm going to press the button, and there is no change, proving our fault is south of connector 201.
So the next step was to move my test south of where I first tested. We tested up here at the BCM and everything was available. However, now I'm going to test here at C201 because it was easier to get to than the tow haul switch itself. So referencing C201 terminal B5, which is my light blue wire with my red meter lead and my black meter lead on a known good ground, I have approximately 12.5 volts available. However, once again, when I depress the tow haul switch, that voltage does not drop. So proving once again that the circuit is integral all the way up to my test point and leaving everything below this as a potential suspect. So now, since we've eliminated G203 and we've eliminated everything north of my red alligator clip here, it leaves only the tow haul switch and related circuitry between the switch itself and connector 201, meaning this entire wire here and this entire wire here, including the switch, as a potential fault. More importantly, it gives us justification to disassemble the clamshell now and go looking around.
So now that we have the steering column accessible, I've got my shifter here, and of course my button for the tow haul mode selection is right at the top of the shifter. But we're going to keep our eyes out for anything suspect. So I want you to watch something. As I cycle this shifter, watch that this orange wire harness here. This houses the two wires for our tow haul mode. I guess I should turn the key on, that helps. Just watch that orange wire. It flexes, that flexing has me concerned. That's a stress point. So using some logic here and just investigating, take a look at what I found here. Let me see if I can get in for a better shot. Oh, sorry, I know how tough this is to watch. It's very difficult to do this. I'm hanging upside down right now. Look, one of our wires has broke. It's up in here. There it is. It broke right inside that secure tab. So we've already bypassed this and proved the bypass test works. But that gave us a stepping stone to move forward with further disassembly.
So to recap, we referenced the wiring diagram to learn how the circuit was configured. Understanding that it is computer-driven, we referenced data, or at least attempted to, from the body control module, which is the receiving unit, and the instrument panel cluster and PCM, which will then get the messages from the BCM once that signal has been processed, neither of which offered available data. So we had to do things, I'll call it, the harder way. We began at the easiest test point, which was at the BCM. It was easily accessible and approved voltage was available, meaning the body control module was outputting the signal. By creating a bypass test and jumping that signal to ground, we proved that that circuit will function normally, giving us justification to pursue south of our test point. It led us to a potential bad ground, G203, which we proved to be okay simply by looking at the wiring diagram and realizing every other component that utilized that ground was functioning just right. Due to a process of elimination, there was no need to physically test or inspect G203. So the related circuitry in between G203 and our test point at the body control module led us to two potential fault areas. One behind the clamshell of the steering column bezel, and two at connector C201 behind the knee bolster. Knee bolster being the easiest component to remove with two fasteners and some retention clips. We had it off in about 2 minutes. It was easy to access connector 201 terminal B5, the light blue wire, and proving the fault was once again south of that on the wiring diagram, leading us up to the clamshell. Justified removal of the clamshell for visual inspection. By manipulating the shifter, we could see a suspect area simply by way of how the wire harness flexed. And you know as well as I do, we move a paper clip like this back and forth several times. Eventually that metal was going to weaken and break, and that's exactly what happened. So we are going to be performing a wiring repair. The correct repair would be to replace that shifter assembly, but this is my personal vehicle, and I have no problem repairing a wire. I'm simply going to repair that wire and verify that the system once again will function correctly, restoring that ground path through the tow haul switch to G203. So again, my friends, this is the bypass test, and I implement this test as often as possible, regardless of the system I'm working on. As I mentioned earlier, sometimes this test is a bit impossible to do because when we're talking about a discrete signal like this, either switch open or switch close, it's not a big deal. But when we are talking about something that might be multiplex, for instance, a specific value that is delivered when a ground path is created, that's a bit more difficult to manipulate, to simulate. So it may or may not be possible. But again, the bypass test is your friend, and I urge you to implement it as often as possible. It will save you time. It will make you more efficient and more confident as well. Thanks for joining me. I'm Brandon Steckler, technical editor of Motor Age Magazine, and I appreciate you watching this episode of Mastering Diagnostics. We'll catch you all next time for episode number 15. Take care.